Sawasdee. Hello everyone, my name is Vira and welcome to today's Houdini Tricks and Tips session. This video is a part of an ongoing series, a quick start to Python in Houdini. If you haven't already, I highly recommend you checking the series out, but it's not mandatory because this session was designed as a standalone. In today's session, we'll see how can we set the external editor in Houdini to the editor of your choice. In my case, it is Sublime. And then we'll see how can we create a shelf in Houdini to run Python scripts. And lastly, we'll see how can we use Pyside2 to create a simple UI in Houdini. If you like this kind of content, give this video a like and consider subscribe to the channel. It will let me know that you like this kind of content, so I will continue making them. And it will also help the channel out greatly. You know, all those engagement, algorithm, the boring stuff behind the scene of YouTube. And without further ado, let's get started. So first of all, I just want to briefly talk about the external editor. Basically, let's go to the Python source editor. Let's go to Window, Python source editor. And let's write some Python code. Let's say I want to print something silly, And let's execute the code by pressing the apply button. You can see that has been printed to the Houdini console. And let's say that I don't really like editing my code inside the Python source editor. Houdini offers a feature to launch an external editor to edit your code. If you go to the icon here, a notepad with a pencil, you can open the external editor. Let's press it. And you can see that it launched a text editor for me. And in this case, because I'm using the Windows OS, it launched a notepad to edit the code for me. And let's edit the code. Instead of I will print blah, blah, blah. And I haven't saved yet. And if we go back to Houdini, you can see that right now Houdini is freezing and the change is not being reflected in the internal editor. In order to have the change reflect in the internal editor, I have to save the code and then close the external editor. And you can see that now the Houdini is not frozen anymore and the change has been reflected in the internal editor. But, using Notepad to edit the code is not very helpful. Maybe I want to use other editor to edit the code. In my case, I heavily use Sublime to edit my code, so that will be my choice of external editor. So let's close this for now. So in order to do that, we need to set the environment variable editor in Houdini. We can edit the environment variable by going to My Documents, to your Houdini version, and find the houdini.env. Right click on it and let's open it with any text editor. I will just use Notepad for now. And let's set the environment variable editor equals to the path to your editor of choice.exe. In my case, I'm using Sublime, so I'm going to Program Files, Sublime Text Tree, and I'll need the path to the sublimetext.exe. I'll copy the address here, go back to the Notepad, paste the path to the exe here, and we need to make sure that the slash in the address is actually /, not the /. That looks good. Let's save this one. And for the change to take effect, you need to relaunch Houdini. And let's go back to Python source editor. I'll just rewrite my code here. And I'll just open the external editor. And you can see now it launched Sublime instead of Notepad. Same deal, make a change, save, and close the application for the change to be reflected within the internal editor. And that's how you set the external editor to the application of your choice. And you can go a little bit extra and go to the CG toolbox here and download the Houdini expression editor. I will provide the link in the video description. I haven't tried yet, but this tool will make the change from your external editor reflect in the internal editor in real time. And Houdini will not freeze when you use external editor. But I haven't tried yet just because personally I work in the studio environment most of the time. And of course, in the studio, we are not allowed to install external tools freely. And there's also the legal issue that comes with the external tools. So I prefer to go for whatever a software is providing me out of the box. Alright, with the external editor stuff off the way, let's get started writing Python scripts. So just like in the previous session, we'll open the Python shell. For the sake of practice, let's import the Who module, even though we don't have to because the Python shell by default is already import the Houdini module. We'll do it anyway. And let's say I want to create geometry node inside the object. First, I need to identify the object. I'll use the node function followed by the path to the object. And then I'll create the geometry node inside the object using the function create node. The first argument is going to be the node type name, and the second argument is going to be the name I want to give to the node. So now the geometry node has been created inside the object. Let's go inside. And let's say I want to create a node, but I don't really know the node type name. Let's say I want to create a volume constraint. Maybe I want to create a volume solver. What I would usually do is to create the node from the tab menu first. Let's say volume constraint. Then I'll select the node. I'll go back to the Python shell. I'll grab whatever I'm selecting right now using selected node functions. And in this case, I know that I only select one item. So I'll grab the first index of whatever is being returned. Then I can use the type function to return the information of the node. And here is the node type name. But the type function is actually return the whole node type object. So there are more functions available inside this object for you to use. You can go further by using the type function followed by the name function. And in this case, the node type name is being returned as a string. And because I know that I will use Python to create node over and over again, I know that I will encounter the situation where I don't know the node type name over and over again. So to do this every time I need to find the node type name in the Python shell, it's not very efficient. Instead, what I'm going to do is to write a snippet of code to do just that, save it somewhere to be used over and over again. And to do that, instead of using the Python shell, I'll use the Python source editor. Window, Python source editor. And before we proceed forward, there's something I want to mention about Python source editor. So let's say I write a Python script. Let's say I want to print "We are awesome." I'll press apply to execute the code. You can see that "We are awesome" has been printed. And I'll save this Houdini scene. I'll set the project quickly. Save the scene. Let's save it as Python session 2. Accept. And I will reopen the scene. And if we look at the Houdini console, you can see that "We are awesome" is being printed again. That is because when we open a Houdini scene, it will execute whatever is inside the Python source editor. So with this in mind, just be mindful of what you left inside the Python source editor when you save your Houdini scene. What I usually do is when I develop a snippet of code, I would do it inside the Python source editor because it's very easy to execute the code and test things out. And once I'm done with developing the code, I will copy it and save it somewhere else, leaving nothing inside the Python source editor. Alright, with that in mind, let's get started developing our Python snippet to find the node type name of whatever we are selecting. I'll just delete whatever we have earlier. And before we do anything, just like before, it is a good practice to import Houdini module before you start writing your snippet. And just like before, I'll grab whatever I'm selecting in the network view. And because I know that I will reuse this snippet over and over again, I am sure there will be a situation where I want to select multiple nodes and print their node type name at the same time. I'm not going to grab anything specifically from the index of whatever is being returned. I'll just leave it as it is. Instead, I'll use the for statement to loop over every object that has been returned. For each in cell, just in case you're wondering, each in this situation is basically a representation of the object that is currently being worked on in the loop. And you can basically change each to anything. Maybe you can use for I in cell, for item in cell. You can use whatever you want. And for each object, I will print the type, name. I will select a node in the network view, press apply. And you can see that it returns the node type name, just like how we want it to. And let's say we have more nodes in the network view, maybe a volume solver. And I select them both at the same time, press apply. And you can see that the node type name of all of them is being printed. So that's good. But I want to take things a little bit further. I want the snippet to be able to check if I am selecting anything. What I can do very easily in this case is to use the if statement to check if there is anything being returned from the selected nodes function. If something is being returned, let's print true. If nothing is being returned, let's print false. And I'll just comment this part of the code out for now. You can comment the code by selecting the code and then press Ctrl// and the code will be commented out. Let's press apply. And because I'm not selecting anything, so it prints false. And if I select something, it will print true. And instead of print out true or false, if something is being returned from the select nodes function, I want it to print the node type name. Else, I want to print nothing is being selected. And press apply. Nice, it seems like it print out the node type name. Let's test the snippet out again by selecting two nodes in the network view. Press apply. Alright, it seems like it works with multiple nodes being selected. If I select nothing, then it prints nothing is being selected. So now the snippet is fully functional. Hello there, Future Virat here. As I am editing the video, I feel like I should explain more on the concept of using if statements to check if something is being returned from a function. First thing first, to clarify, every function in Python is actually returning something. And when I say that nothing is being returned from a function, actually the function is returning the none. Let me demonstrate. Let me define a function. Let's call it test function. And I will do a simple math operation inside. Sum equals to 1 plus 1. And I will return the sum. I will have the variable result receive whatever is being returned from the test function. And then I will print the result. And as you can see, it prints 2 as it should. But if we don't return the sum from the function, you can see that it returns none. And in Python, there is this thing called truth value testing. So basically, any object can be tested for truth value to be used, and in our case, in if statement. And none is defined to be false. And as you already know, if statement will check if the statement is true or false. If the statement is true, then it will execute the code. And since we know that none is defined as false, if we use it as a statement, the code will never be executed. For example, let's say if result, let's print yay. And let's delete the print result here. Let's run. And you can see that nothing is being printed. And you can run the function directly as a statement as well. And as you can see, nothing is being printed. But if we return the sum, let's press run. You can see that the code in the if statement is being executed. Because the function is returning something, in this case the sum, so it's not returning the none anymore. That means the statement is not false anymore. That's why the code inside the if statement is being executed. I hope this quick example helps you understand the concept better, and let's get back to the video. Now that we have a functional code, I like to wrap them in a function so they are reusable in many situations. First, in order to define a function, we need a def statement followed by a function name, and in this case, let's name it getNodeType followed by the parentheses followed by colon, and we will select the code we wrote and press tab to indent the code. Now, if we select something in the viewport and run the script, nothing is going to happen yet because we haven't called the function. In order to call a function, we need to use a function name followed by the parentheses. Let's clear our Houdini console and try again. If I select multiple nodes and press apply, you can see that their node type name is being printed. If I select nothing, you can see that it prints nothing is being selected. So that's good. Next, what you can do right away is to take this snippet of code and make it into a shelf button. You can go to the top right of your shelf, go to the plus sign button, press it, and you will have an option to create a new shelf. I'll name it Python Tools and label it as Python Tools. Press apply. You can see that a new shelf is being created. You can then right click and select new tool. Then you can name your tool whatever you want. In this case, I will name it getNodeType label. I just name it nodetype. And then for the script, I'll just copy whatever we have from the Python source editor, then paste it here. Press apply, and you can see that the two names has been changed. Let's select the nodes in the network view and press the button. You can see that the node type name is being printed. If we select nothing and press the button, it will say nothing is being selected. So now you have this snippet of code available to you at all time on the shelf. Even if you close the Houdini scene, when you reopen, this shelf will be available to you. So that's good. But I want to take things a little bit further. I will write a UI with a button to execute this function. In this demo, I'll use Pyside2 to write the UI in Houdini. First of all, let's comment this out. So whenever we re-execute the code, the getNodeType function will not get executed accidentally. And I'll write from Pyside2.qt widgets. I want to import QMain window. And to keep things neat and tidy, I will create a Python class to make the code self-contained. I will name the class Python Tools. And it is a good practice to capitalize your class name, so it's distinguishable from a function. And I will inherit the QMain window here into the class. Basically, it makes our class have an access to the methods and properties of the QMain window class. And we have to initialize our class using the __init___ method. And in the parentheses, we need the keyword self to represent the instance of the class. And we will use the function super followed by .init. Basically, our class requires the super function in order to have an access to methods and properties of the QMain window class. Next, within the init, I'll set the window title using the self.setWindowTitle function. In this case, I'll name the window Python Tools. And in order to show your window, first we need to create the instance of the class, then use the show method. Oops, I made an oopsie here. This Pyside, the S supposed to be capital S. Let's try it again. And you can see that the window has appeared with the title Python Tools. So now we have a basic structure of our UI. But as you might have already noticed, when we show the window is actually too small that our window title get cropped out. So I want to set a default size for our window before showing it. For this, I will use the function resize, and I'll set the width to 250 and the height to 100. If we show the window, you can see that the window has been resized, and you can manually resize your window later as well. Next, I'm going to create a button, and in this case, I need to import more things from the Pyside2.qt widgets. So I will have a comma here, and I will bring in QPushButton, and I will create a button here. I will use the QPushButton, and I'll give it a label print awesome. And then we will have to parent the button to the window. And in this case, because we haven't created a layout yet, we will parent the button directly into the main window. We can do that by using the function called setCentralWidget, and in the parentheses, we will put in the button. If we press apply, you can see that now there is a button in our window, which currently is doing nothing. So let's say for the testing purpose, I will create a function called print awesome. We also need the keyword self here in the parentheses, and I'll have it print we are awesome. And in order to connect this function to the button, we can use click.connect function, and inside the parentheses, we will need self.functionName. Let's press apply, and let's clear the Houdini console first. If you press the button, you can see that we are awesome is being print. So that's good. So instead of print awesome, we want the button to be connected to the getNodeType function that we wrote earlier. So I will grab all of this, cut them, move and paste it up here. And I'll select the code, press tab to indent selected. And we need the keyword self inside the parentheses in order for the function to work inside the class. And we can just simply change the function name here. And let's change the label of the button as well. Let's call it getNodeType. Press apply. Let's select the nodes in the network view. Press the button. Now we have a UI with a working button that executes the function we wrote. When we select the nodes in the network view, it prints the node type name. When we select nothing in the network view, it prints nothing is being selected. So it's working as intended. Let's tidy things up a bit. And we don't need this last line anymore. I want to take things a little bit further. Since we have two functions in our class, I want to make a button for each function. A button to print awesome and a button to get node type. And because we will have two buttons, we will have to create a layout for the UI as well. We already have a button for get node type. Just to make things less confusing, I will rename the variable to button underscore get node type. Let's just abbreviate it to GNT, and same here. And I will comment the set central widget out for now. And I will create a button for print. Same deal, to push button with a label print awesome. And we will connect the function to the button using the clicked.connect function. And inside the parentheses, we will put the self.function name. Next, we will create a layout for the buttons to be residing in. In this case, I know that I need to import more stuff from the Pyside2.qt widgets. The first is going to be QV box layout, which I assume stands for Q vertical box layout. And also we need to import the Q widget. First, I will create the layout using the QV box layout that we imported earlier. And I will parent the button to the layout using the add widget function. The first one is going to be the print button. I'll do the same for the get node type button. And then we have to parent the layout to a widget. So first, I will create a widget using the Q widget we just imported. And I will parent the layout to the widget using the set layout function. And lastly, we have to parent the widget to the central widget. So instead of parent the button to the central widget directly, I will parent the widget which has the layout which has the buttons to the central widget. Press apply. And now you can see that we have two buttons inside the vertical box layout, inside the widget, inside the central widget. If we press print awesome button, it will print we are awesome. If we select nodes in the network view and press the get node type button, it will print their node type names. So the UI and the tools are done. So I will put them on the shelf so that they can be used later. Copy the code, right click on the shelf, new tool. On the script tab, paste your code. Let's go to the options tab. Let's name it Python Tools UI. And the same for the label, except for the underscore. Press accept. And now the tool is available to you at all time. And don't forget to remove everything from your Python source editor. So when you reopen your scene, nothing will be accidentally executed. So that will be it for this session, and I'll save the code that we go through together today. I will put it online somewhere, and I'll put the link in the video description. And that is it for this video. I hope it is helpful and enjoyable. Well, at least I have a lot of fun prepping and making this video. And if you have any questions, suggestions, or anything at all, you can always comment in the comment section down below. And just to let you know, I enjoy interacting with you guys' comment, and some comments were very sweet, so thank you. And see you in the next video. Bye for now.